I'm Mr. Kangas, and today we're going to be taking a look at Chapter 8, Section 1, Solving Equations with Variables on Both Sides. So in the past we've solved equations such as 2x plus 3 equals 8, where we had a variable on one side of the equation. Today we're going to be taking a look at equations where you still have only one variable, and what I mean by that, like we still only use x, or we still only use a as our variable, but this time that variable is going to be on both sides of the equation. So you might see something that looks like this, which at first may seem kind of confusing, but if you understand multi-step or two-step equations, or even one-step equations, this isn't really a whole lot different. There's really just one extra step. That one extra step is to get the variable on one side of the equation instead of both sides. Because our goal is still to figure out what x equals. The only difference is now we have an extra step. So we need to get the variable onto one side of the equation instead of two, because obviously I can't solve for x if it's on both sides of the equation. Because I want to know what x equals as a number, not what x equals as x. Wouldn't really make a whole lot of sense to do that. So you're still going to follow the same rules. Same rules still apply. This equal sign is still telling us that the left side is exactly the same as the right side. So whatever I do to one side also happens to the other side by default. It's like, for example, if you gave Mr. Kangas $5, then you've also given Justin Kangas $5. We're the same person. What you do to one has to happen to the other. So what we're going to do is, the first step we're going to take is we're going to get that variable onto the same side of the equation, onto one side of the equation. And this is where you have a little bit of choice. You can choose to get rid of the 4 to move the 4, or you can choose to get rid of the 2. I'm going to move the 2x because I know that I need to subtract 2x from both sides to get rid of it. And 4x minus 2x isn't going to get me a negative answer, and I like to avoid negatives if I can, just because it makes the process simpler. So I'm going to subtract 2x from both sides. And what you're going to see in the red is just that subtracting 2x from both sides that I'm inputting. It's the what's new to the equation. What wasn't up here that is down here, it's the minus 2x. And I have to do it to both sides. And remember, you can pause this at any time. You can rewind it if you need it to slow down, or if you need to hear something over again. And so when I do 2x minus 2x, the whole point of subtracting 2x to begin with was to cancel this 2x out. So those end up canceling each other out because they're opposites, and we're left with just 5. 4x minus 2x is 2x, and we're left with 5 equals 2x minus 7. At this point, we just have a two-step equation. I need to get rid of the minus 7 and the 2 that's being multiplied by x. So as usual, I'm going to get rid of the number that's by itself first, not the number attached to the variable. The 2 is attached to a variable, so I'm going to get rid of that last just to make this process easier. So I'm going to get rid of the minus 7 first, which means in order to get rid of that, I do the opposite, and I add 7 to both sides. And again, in red is the plus 7 I'm doing on both sides. Okay, so the 7's cancel out. We're left with 2x on the right side. We're left with 12 on the left side. Last step, it's a one-step equation. We have 12 equals 2x. So to get rid of a 2 that's being multiplied, we have to divide both sides by 2. So 2x divided by 2, the 2's are going to cancel out. That was the whole purpose. This 2 is being multiplied, this 2 is dividing. So if I take any number, which x at this point we don't know exactly what it is right now, but if x were any number in the world and I multiplied it by 2 and then divided by 2, we would be right back at x. So the 2's cancel out, we're left with x. 12 divided by 2 is 6. So my answer for x is 6. And you can check that just simply by plugging 6 in for x and see if it works. So on the left side we have 2 times 6 is 12 plus 5 is 17. So when I plug in 6 on the right side, I should also get 17. So we do 4, plug in the 6 for x. 4 times 6 is 24, minus 7 is 17. So 6 is the correct answer, and I confirm that by plugging my answer in for x, and it did work. Both sides are equal. And that's really all there is to solving an equation with the variable on both sides. If you need to rewind, rewatch, pause this video at any time to get all of this, or to hear something again, please do so. But also keep in mind that you may have some decimals thrown in at some point. You may have some fractions thrown in at some point. That doesn't really change the game. We've discussed that before, I believe in chapter 5. All the decimals do is instead of doing 5 plus 7, I might do 5.3 plus 7.2. So you just have to know how to add, subtract, multiply, and divide with decimals and fractions if you see those thrown into the equation. And so that is it. Tune in for Chapter 8, Section 2, since there really isn't anything else on Chapter 8, Section 1.